technology that we were hoping for and the broken robot that is most of those other projects. Hi, my name is Naveed Ihsanullah. I'm head of engineering research here at Algorand, and I'm really excited to be presenting to you today on Algorand, the project, the team, and how we're defining the standard for blockchain technology. You know, before I sort of get into what Algorand is, I want to sort of make the case for why we're here and why blockchain could be really important. And we mentioned, some things in the very beginning at a high level, but let's make that concrete with regards to the world's financial system. There's this amazing opportunity in front of us. Financial systems touch every aspect of our lives, but especially recently, they've sort of failed us. Their services are unavailable to 2.2 billion people. That's, I think, a quarter of the population. They have lost our goodwill in recent years, especially among the youngest generation. And I think for me, most interesting is this last number on the slide. 6% of the world's economy is simply lost in the friction of these cost inefficiencies and transaction fees. Algorand, launched our mainnet a little over 6 months ago to prove our core technology. Only in the last month, with the successful upgrade to Algorand v2, did we truly enable some of the most exciting DeFi use cases. Since we are a newer project, I'd like to introduce all of you to our team. Algorand was founded by cryptographic pioneer Silvio Micali. Probably many of you have heard of him before. He's co-inventor of public key encryption infrastructure, zero-knowledge proofs, and verifiable random functions. With him are a distinguished group of researchers and proven business leaders. Algorand is also lucky to be bolstered by some economic and scientific advisors that include founders of both Zcash and Coinbase. I'm part of Algorand Inc., the corporation, and I think of us as the implementers of the Algorand technology. There's also a Algorand Foundation based out of Singapore, and I think of them as the stewards of the running network. They are responsible for defining the requirements of the system and the financial and economic policies that govern it. Algorand Foundation has its own collection of world-renowned researchers, economic advisors, and business leaders. And of course, blockchain is very, very community-based. We definitely recognize the importance of community in blockchain and have worked very hard over the past year, 18 months, since Algorand's really been around, to grow that. And I'm very proud to say that we have more than 35 ambassadors around the world in over 32 countries. And of course, we have representatives like Gokul helping us in India. So blockchain touches on many different disciplines: economics, finance, governance. But blockchain platform, however, really rests on the quality of its technology. Back in June, as I mentioned, we launched our core technology, our V1. And at the heart of that technology is something that we call pure proof of stake. This is the innovation that allows our blockchain technology to securely support the needs of the entire planet. To understand what we did and how we're different, I want to take a look at what blockchain really is. At its heart, it's a really simple concept. It's a bunch of blocks, and they're connected in order. The blocks could contain anything, but they typically contain transactions that transfer money from person A to person B. Each of these blocks are securely linked using cryptographic techniques that were really well understood and have been around for decades. Extending the chain is really easy. You take the hash of the previous block and you stick it in the next block, and then you have your link. The hard part with blockchain, the real challenge, is how do we select that next block? So I can sort of see people in the picture here. Have people heard of the strategy called proof of work? Can I see a show of hands? Some? Yes. So proof of work was made popular by Bitcoin. Ethereum and many other projects use it. It's the first sort of strategy to have this decentralized idea of how do we pick the next block. But it has some issues. It's very expensive. It sort of concentrates power in the miners. It has questionable security. And one thing I think is really interesting is a blockchain is supposed to be a chain, but a proof of work system typically ends up with something a lot more messy, this tree that we have here. So it was a great idea. It was the first idea, but I don't think it's what we need moving forward. There's a lot of other approaches as well. Besides proof of work, there's delegated proof of stake, where instead of having everyone in the system consider and decide on the next block, we pick 5 or 10 people. Bonded proof of stake is only those who have given up some money as proof of their good work. Those are the only people allowed to vote in the system. And all of these approaches have their pitfalls, but I think what I find really interesting about all of them is they have this twisted idea of the security of the entire system is actually protected by some special class of people, whether it's the miners, the delegates, those rich enough to actually afford to take out a bond. In Algorand, in pure proof of stake, there are no special users classes, and the whole system is protected by all of us working together. So let's take a look at what Algorand, the blockchain, looks like when it's in operation. Here we have the Genesis block, the first block of any blockchain. That one you get for free. No one has to decide on it. It's part of the system definition. Excuse me while I have some coffee here. And next to it, we have this feather. And as you see this feather unfurl, you can see the blockchain elongate. In Algorand, the blockchain is clean. There are no forks. It looks nothing like a proof of work system. Everything in Algorand, as soon as it enters the blockchain, it's immediately final, and participation is easy. There's no complex mining or cryptographic riddles to solve. So how do we make this work? Well, sort of conceptually at a high level, we pick a random user. And that random user chooses a block and propagates that block to the network. And then we select a small committee of people from the entire population. So if there's 8 billion of us on the planet, we only pick 1,000 people for this committee. But it's statistically representative, so it's represents all of our decisions safely and evenly. And once that committee quickly decides on that block, it's signed and propagated to the network, and the network is elongated. So the sort of power behind Algorand is these committees that we build. And what I'm often asked is, well, it seems like these committees are a problem themselves. How do you pick these committees? And this seems to be like the part of the protocol that is, if built poorly, can easily be broken. Well, the secret sort of cryptographically and mathematically hidden here is everyone on those committees, they pick themselves using a cryptographic lottery that they cannot influence or cheat on. And every single block, multiple times actually per block, we select this committee. So we're constantly sampling over the entire population of the world. And once the committee is done, it sends its vote and moves on. So you can't attack the committee. By the time you know who's involved, they've already done their work. So it's super scalable and super secure. The core technological benefits of Algorand are there's practically no real work involved. It's so efficient it could be run on a Raspberry Pi. You certainly don't need a complex ASIC miner operation to be involved. It's secure against every kind of attack we can imagine. In fact, it's even secure against network level attacks. If someone is able to cut wires and play with the routers, you could break any proof of work system and even most of the proof of stake systems that exist. But Algorand, the worst that you could achieve is to pause this temporarily. As soon as the network attack stops, the DDoS runs out of money, we go right back to where we were. And we operate incredibly quickly. 1,000 transactions per second today. We have line of sight to increase that by over an order of magnitude. And we generate a block since we launched back in June in about 4.3 seconds. And we certainly can make that faster. We just have to twiddle some constants in the system as we decide that it makes sense. One of the problems with Algorand is we're so fast, we actually generate data very fast. So unless there's a pressing need to be faster, we're sort of picking a balance point that makes sense. So that's where we were back in June, and that's what we proved for the 6+ months. Our core technology, our innovation, it definitely works. But it's really here, more recently, November 21st, that the Algorand Foundation announced the availability of our version 2 upgrade. That powerful collection of features that really enables this boundless opportunity to build amazing applications and businesses on Algorand. So a quick word on upgrades. Algorand, we use Byzantine agreements. At its core, as I mentioned earlier, and 99% of the time, we use that agreement to decide on the next block. But we could decide on anything. We could decide on who the president will be, who the mayor will be, and certainly what upgrade the system could agree on. Because the system was designed to vote on upgrades, we will never have an issue where a hard fork of the protocol will cause two divisions in the population. The scenarios that happen with Ethereum and Ethereum Classic and Bitcoin Cash can't happen with Algorand. When we did our V2 upgrade, 100% of the network, all the nodes, all the users moved over to the upgraded network and were able to participate with no loss of users and no loss of value. So the first of these new features I want to talk about are Algorand standard assets. Are people here familiar with Ethereum ERC20 tokens? Can I get a show of hands, anyone? See a couple of hands in the front, maybe more hands in the back? Great. So Algorand standard assets are, excuse me, I think it's been forward there. Algorand standard assets are our realization that the vast majority of smart contracts are used in a couple of different ways. And the most common way probably is to create some sort of digital representation of value. And ERC20 is one of these standards. ERC 721, 1400 for non-fungible and security tokens are other standards that are often used in the Ethereum world. These are digital standards that allow us to create a monetary supply or to represent CryptoKitties or even to indicate whether I have Apple stock and who's allowed to transact in those stocks. In Algorand, we decided that this is such a common operation. Instead of writing an error-prone smart contract, let's make that a base feature of the protocol so you can get all the security guarantees and all the high-speed performance of our layer 1. So some of the things that are possible to do with these ASAs are, like I said, generate this fungible token or non-fungible token or security token. And we even support powers such as freezing. And this is the manager that builds a supply of tokens can allow anyone to transact in the token, or they can say only a certain class of user is allowed to transact. Everyone else is frozen, or everyone's allowed to transact, and because I did something that was questionable, they're going to temporarily freeze my accounts, so I can't transact in the Naveed coin, for example, until they do some sort of analysis, determine what happened was okay or not, and then freeze or unfreeze as appropriate. That power is quite powerful, and I think there's people in the crypto world that are not happy to see these restrictions come to a standard asset. However, some entities like stocks are involved in a lot of laws. Governance and legal pieces are required to be there if you want to trade in those securities. So we realize we want this functionality. However, to make it so people will trust that they opt into an economic system that makes sense to them, if you ever turn off these features, like the ability to freeze, you can never turn it back on. So if someone creates the Naveed coin and you look at it and it says the freezing power was never taken, you can rest assured that that ability will never exist in the future. However, if I create a stock class, for example, for my Apple stock or what have you, Facebook, you name it, that will probably be a power I keep so I can obey the regulations that apply. One other word on ASAs, the Algorand Standard Assets, as they are opt-in. This is because Algorand Standard Assets take up space. When I decide I want that asset to be part of my balance, it will take up space in my account, if you will. And so I have to say I want to transact in that. Otherwise, no one can send me that kind of currency. And that you can see it as both a feature and a restriction. It has utility, but it certainly saves you money from just people DDoSing you by sending you all sorts of assets you don't want. The next functionality that launched with our V2 protocol is atomic transactions. So before I talk about the exact feature, I just want to talk about atomicity and atomic swaps generally. Let's first consider a scenario where not atomic transactions and swaps don't exist. I'll pick someone in the front row here. Let's get involved in a transaction. You're going to give me your car, and I promise after you give me the keys and I drive away that I'm going to pay you. It seems like a pretty safe thing to do, right? Well, so the concept around swaps are there can be third-party risk or second-party risk. Once you grab your part of the asset, you aren't really incented to pay them. An atomic swap, though, is very different. It suggests that user one and user two get involved in a contract. In this case, they both signed a transaction, and then both of those transactions go into the blockchain simultaneously. So either the whole thing goes in, A swaps for B, and B swaps for A, or none of it will go in. So it's a single transaction, and it's the way trading really should happen. What we did is we made it so atomic transactions are built into our Layer 1 protocol. In most blockchain systems, this is something you'd have to do by creating a smart contract. And once again, we see smart contracts as being very powerful and expressive, but they are very easy to get wrong. So if most of the common smart contract functionality is templatized and easy to implement with a transaction, we would rather have the users go that route. So our atomic transactions aren't just for bilateral exchanges of a car and some money, but it could even be a group of transactions. We could have all of us sit down for dinner, all of us pay one person, that one person uses their credit card, for example. Once again, all the transactions will go in or none of them will. And so it's completely safe. No one takes any additional risk. This eliminates one of the sort of hard transactions and smart contracts to get right is this concept of a hash time lock. This is necessary for doing cross-chain swaps and cross-asset type swaps where atomicity doesn't exist. But with atomic transactions, you don't have to take that risk at all. And as I mentioned, you can use this for bilateral exchange, circular trades, group payments. There's many, many different ways to use this. In fact, with some additional logic, you can even use this to implement a decentralized exchange. So the last piece of functionality that came sort of in the big bucket of our V2 are Algorand smart contracts layer 1. Algorand smart contracts in layer 1 are extremely small, fast logic expressions that allow for massively powerful computation that does not slow down our blockchain at all. One of the things that I was very concerned about when looking at programming and smart contracts is you have something as successful as a CryptoKitty, and it takes over the entire network when it's being born. If that is going to stop regular transactions from going in, it doesn't seem to be a very ideal situation. So we want to make sure that our logic, our programmability did not slow down our 1,000+ transactions per second at world scale. And so what we came up with is a Algorand smart contract in layer 1 uses something, a small, simple assembly-like language called TEAL, which stands for Transaction Execution and Approval Language. And TEAL does something very, very simple. All it does is it's programmatic logic that will evaluate into either a 0, which means don't do it, or a non-zero value, which means this is approved. And you attach that to various different places, and if it evaluates to true, then that transaction will go in. With that, it's now possible to build escrow accounts, low payments, limited stop orders. You can set up a collateralized loan and have someone pay it at a particular interval. And if they don't, then whatever they put up for their bond, you could take back. The TEAL language is what powers all this logic, and it's a simple bytecode language that is stack-based. It can replace the signatures that you'd normally use your signing key to sign a transaction. You'd instead write this TEAL script that says, if these conditions are met, then this transaction is good. It's somewhat similar to Bitcoin script, but since Bitcoin is UTXO based and has a lot of functionality, is rather missing a lot of functionality that Algorand has, you can't do many of these things in Bitcoin script. And one of the things we want to do is we want you to get up and going as quickly as possible. So we built a bunch of templates available at the site that you can investigate when you're trying to build your own TEAL scripts. So there's two sort of primary ways in which you can use TEAL scripts. When you can use them as a contract account, and when used as a contract account, the TEAL code is compiled and it will return an Algorand address. The contract account address can be used to send algos to it or regular algo standard assets using normal transactions. When sending from a contract account, the logic in the TEAL program determines if that transaction is approved. So that contract account might be an escrow account that says, in 60 days, if Naveed has paid me $10,000, I will release the car. And that's a sort of simple way to understand how this could work from a contract account perspective. Now, unfortunately, this delegated signature workflow is wrong. If you'll see, it's exactly the same one as before. So you sort of have to use your imagination here. The other way to use the TEAL logic script is in these delegated signatures. What this means is essentially you replace your signing key with a TEAL logic sig with a bunch of rules. And you just pass that transaction to anyone, and they can use that transaction with your authority and then put it into the blockchain. And so, for example, I could create a delegation that I give to someone in the front row that says you can move, 5,000 algos every day from this account. So basically, giving you the ability to spend petty cash in a safe manner without taking all the money that happens to be in the business account. So that's a quick overview of the technology that's in play here in our core protocol. But Algorand is more than just technology and a base layer protocol. It's a complete platform. We have focused on, at every step, on identifying partners and use cases to help focus us, to give us the best user experience for you, to help people build businesses and technologies on top of us. We sort of looked around and figured out what the top development languages are, and we have SDKs in Java, JavaScript, Go, Python, and more are being added all the time. We're engaging with communities and universities for ideas, getting feedback to help us improve, and engaging with motivated partners who are passionate to build DeFi products. So there's over 100 people in the 100 projects currently being built today in the Algorand ecosystem. More and more, like I said, are being added every day. Some that I like to highlight here are Asset Block. They're tokenizing commercial real estate using the Algorand standard assets to represent, for example, a building, and then allowing for fractional ownership in that building. IDEX is the largest decentralized exchange currently on Ethereum, and they're moving their implementation, so they have one on Algorand. And then Tether, USDT, probably the best-known stablecoin, is working on their Algorand implementation right now, and hopefully should be released shortly. We also have a growing list of partners to help out flesh out the Algorand platform. Infrastructure providers. Blockchain can often be an IT project. You have to run a node, you have to have database, you have to have all this computer infrastructure just to get going. And what we did is partnered with groups like PureStake that can offer blockchain as a service. We are working with financial products to help define standard assets like loans, et cetera, that are used by all the major financial institutions today, and that you can templatize and instantiate yourself. As I mentioned before, we also have a bunch of universities that are helping us flesh out and give us ideas along the way. And I guess I want to end here and give you sort of an opportunity to ask me questions. But we have a really rich set of instructions at developer.algorand.org. They'll teach you about the platform, how to build, get access to our SDKs, show you the forums, links, and other places to connect with us if you want to start building today. So at this point, I'm happy to take any questions you may have about us. I know I gave you sort of the whirlwind view of Algorand, but I didn't go really that deep into technology to see really where your interests lie, and we can sort of take it from there.
Any questions? Can you hear me?
I can hear you, yes.
How do you compare this platform to this evolving other platform like Tezos? And I get the similar type of message from the last stop of the blockchain, the new blockchain. So how do you compare it to what is used?
Yeah, sadly, while I can hear that you're talking, I can't actually make out your words. Is it possible maybe for someone to type the question to me in the Zoom session? I'm going to actually stop the presentation so I can see the Zoom. Okay. All right, here, I can finally see the chat. So can you help compare this with Tesla's blockchain? What is the USP here as compared to that? I don't quite understand USP. Actually, I have to admit, I don't fully appreciate how Tezos is implemented. It's one of the blockchain protocols I have not done much research on. So I will have to get back to you on that one. Maybe you can send an email link to me, and I will be happy to sort of go into that in more detail. But what is this acronym USP here as compared to that?
Yeah, so we have a panel discussion with Naveed. So home is right there is Naveed and then the Foundation. So after this conversation, I mean, we will be ready to answer this question. Right? Any other questions? Yeah. You were talking about TEAL, right? TEAL, which is
Yeah, there's a massive echo, so someone will probably have to transcribe the question into the Zoom chat for me to be able to understand it.
My question is, how do you ensure security in the TEAL system? Because as I understand, TEAL is a replacement for private keys for signing transactions. So if you are not using private keys to sign transactions, you are using the TEAL system. Can't anyone hijack someone else's transaction and send it to you? How do you ensure security?
That's a great question. Okay, so let me repeat to make sure I understand. I think you're asking, using our layer 1 smart contracts and the TEAL approval language, how do you assure security? If we're not using public-private keys to secure things, then it feels like there could be issue here with security. Well, that is definitely a concern. It's quite possible to write, if the simplest possible TEAL script would be pushing a 1 onto a stack and then returning. And what that would basically say is, I approve everything. Now, if you attach that script to an account that has $1 million in it, then anyone could transfer $1 million out of your account and you would just simply lose it all because the TEAL script approved it. So this is an area that we are doing active research. And one of the reasons why we built these templates for you to use when it comes to TEAL is so you have pre-built TEAL scripts that have been rigorously evaluated for correctness, so you can reuse them. And the next part of this is if anyone can write a TEAL script, we are a decentralized system, so anyone can write their own. But we want to provide tooling that makes it possible to easily formally verify your TEAL smart contract. So you end up with only the level of approval that you wish, and there'll be best practices around that as well, where you definitely carve up your value and create these special contract accounts, so you limit the loss that's only attached to that. Instead of your full amount of money, you create a one-off account that has maybe a week's worth of money or a month's worth of money. So if for some reason all the tools fail you and you write a TEAL script that can be exploited, you're not in a position where you lose everything. But it's a very good question, and I think smart contracts, this is one of the reasons why we are trying to give you as much functionality without them as possible, is because they can be a security issue if implemented improperly.
Other question? Okay, so no more questions about the Algorand project. So yeah, is there a way to how do we get involved there? Do we build on Algorand? Do they get onto the channels that you shared at the end of the slide?
Are you asking me if is it possible to share the slides?
Yeah. So I was just so there's many of the people here are looking at building apps, right? And so the idea was, is there a way to connect if they're looking to build on the Algorand blockchain? Did you get that?
I am hearing you twice, so it's very, very hard to parse. How do people that decide to build an Algorand blockchain connect with the team? It's a great question. And I alluded to this earlier. I think that slide I had at the end, developer.algorand.org, is the primary resource for building an Algorand. At that link, you will find access to getting on our forums, and the developers, our development relations folk are all actively engaged on those forums, are constantly talking with anyone who's building. So it's probably the best way to connect with the team. You can certainly find most of us on Twitter. It's another way to connect with us. But if your question is technical in nature, how do I build? How do I do that? The way I would think of that is start with developer.algorand.org. If you cannot find it in our the instructions that are written there in the documentation, then use the forums as a place to post, and someone will get back to you right away from the team, from DevRel, and often even from the community. There's, like I said, there's now hundreds of different projects building on Algorand today, so there's a lot of folk who know how to build successfully and well.
Sure. Okay. I think Naveed, we've done so. All of our questions have been answered. Thank you so much for the lovely introduction. And are you okay if we pass on the slides to the community?
You can totally pass on the slides. I'll send them over to you. I think I already did. Yes. Absolutely. It was a pleasure talking to everyone. Build on Algorand. I'm looking forward to seeing what dApps you come up with. Have a great day.
You do back.